Well, hello there! I hope you're having an amazing day and that you're feeling as excited as I am to talk about integer overflows. We already mentioned this concept in previous videos, but right now it's time to actually learn what it means and how to find it properly. Ready? Let's go! Of course, our first topic is going to be what integer overflows are actually. So we need a definition for this concept. We will be doing exactly that, and we will be starting with the official definition for the overflows. And after that, I will try to add some touches of my personal understanding and what I think is a simpler and more manageable way how to explain this concept. So, let's get started. An integer overflow occurs when arithmetic operation generates a number that cannot fit inside of the memory location that is dedicated to the variable we are trying to assign the result of this arithmetic operation into. I know this might seem too official and too clean for the real life, so that is why I'm going to try to explain it in a bit more detail, so we would get a better image about this concept. You do remember that each variable has to have a data type assigned to it. And each data type is going to define how many bits in memory are going to be allocated for that particular variable based on its data type. So when we try to assign a value that is bigger than the maximal value that can be possibly technically stored inside of that number of bits in memory, we're going to get an overflow, because it is just impossible to do it. It's like trying to display a number billion when you have only 6 digits to display number. So it is just not possible to do it, because you do not have enough digits to represent that number. Of course, it also works in the other direction. If the number is smaller than the minimal value that can be represented by a certain data type, it is again going to cause an overflow. It's just a different direction, everything else is the same. So basically, an overflow is the problem when our compiler cannot fit the number that we got as a result of some operation inside of the variable that is supposed to be holding the result of that operation. I hope I managed to make it a bit more clear and easier to understand. Okay, I hope that now you understand overflows a bit better. But now let's focus on this topic, but only inside of Rust programming language, because all the stuff that we were mentioning up to this point was a general discussion, and it basically applies to almost every programming language out there. So, the first thing that you should always have in mind is the fact that Rust observes overflows as corruption of the memory. And if you think about it, it makes perfect sense. You will see when we talk about overflows in practice in our Visual Studio Code, what kinds of results are we getting for each overflow. Okay, the next thing that we need to know is the fact that Rust has 3 different things that it can do when overflows takes place. The first scenario that we have at hand is going to happen when we are in the debug mode. So basically, when we are running our application and doing it in debug mode. In this situation, the compiler is going to panic every time that we have an overflow taking place. And this makes perfect sense, because that way compiler is going to bring our attention to some parts of our code that are potentially going to be able to break our code in release mode. So we can prevent that from happening before we get to that point. So basically, you will get notified that you have some places in code where you should pay more attention and try to handle overflows a bit more gracefully. Of course, as I already mentioned, the second thing that can happen is going to happen in the release mode of our application. So when we run our application in release mode, Overflows are not going to be a breaking change. Our program is not going to stop running when an overflow takes place. It is just going to result in unpredictable results being stored in our variables. And as I already mentioned, we're going to see that in action when we jump to our exercises. And the third option is the explicit one. So here we're going to be able to specify what is going to happen explicitly when an overflow occurs using attributes in our code. Attributes! What are attributes, man? Ah yes, attributes. Attributes are basically pieces of code that we can apply to a certain line in our code. So basically, we use square brackets and the name of the attribute that we want to be applying to some line of our code, and we are going to basically apply some additional functionality, and we will apply some additional information to that line of code to our compiler. So our compiler, when it reaches that line, will know that it needs to execute some additional stuff or to change the flow of things executing based on the fact that we applied some attribute to that line. Aha! Way better now, thank you. Now back to our discussion about explicit ways to specify to our compiler how to handle overflows. So, as I already mentioned when describing attributes, when we apply a specific attributes to our potentially overflowing line of code, our compiler is going to know how to behave in scenarios when the overflow occurs. And that way we can basically evade the default behavior for both debug and release modes and maybe do something differently, or use the release approach in the debug mode or use debug mode in the release approach. Whatever you need to be happening, you can do it by using attributes. And now there is no better time to jump right to action and see how overflows are behaving in our real-life examples. So let's jump right to Visual Studio Code. Welcome, my dear friends, to the Visual Studio Code environment. Today we will master overflows in Rust and also proper ways how to treat them and handle them gracefully. Okay, let's open our project and see what I prepared for you. As you can see, I have prepared a few variables and all of them are of type U8. And as you can see, not much is happening here. I just assigned a value 255 to our first variable, and I just want to remind you, the U8 data type has a valid range of values starting from 0 and going all the way to 255. So the value stored in our first variable is basically the maximum valid value for the U8 data type. And as you can see, our compiler does not seem to complain too much, even though we are adding value to the maximal value of our variable. And when I run the program, the compiler starts complaining and we get a panic. And that is because we are in the debug mode and we are supposed to get a panic from our compiler, if you remember our discussion from earlier in this video. And as you can see, our compiler is very clearly telling us that the problem is the fact that an overflow takes place. Now, if you remember, we can suppress this problem by going to release mode of our application. And I'm going to do just that. And to do that, we just run cargo run command, but this time we add a flag called release, so -- release. And when I run this, we will get everything working. Everything seems to be working just fine. But the values that we are getting as results might seem a bit weird. Okay, let's start from the second variable. So for the second variable, we are adding 1 to our first variable. And that is going to result in value 0. Why is that happening? Well, because if you remember, the maximal value for our variables is 255. So when we add 1 to that value, we are basically just going to start from the beginning again. So the story here is very simple to the one of the way how odometers function on our cars. So when you reach 1 million kilometers, odometer just continues from zero. That's exactly what is happening here. When the maximal value is reached, it just starts from the bottom all the way up again. So it starts from zero in this case. So that is what we get as a result. Okay, now what is going to happen in our third variable when we assign 5 to the first variable? So we're just going to count up. When we add 1, we will get 0. When we add 2, we will get 1. When we add 3, we will get 2. When we get 4, we will get 3. And when we add 5, we will get 4 as a result. Which is basically exactly what we are getting here. So everything seems to be working exactly the same as in our previous example. And in our final example, we have variables test3 minus test1, which is basically 4 minus 255, which would be minus 251. Well, in this scenario, we do not have negative values, so let's see what we get as a result. And if you take a look, we get 5. What? Do not worry, please, here comes the explanation. To understand how we actually get 5 as a result here, we are going to be needing some graphical explanation. So I have prepared the following slide for you in order to explain how things are actually working when our compiler is trying to actually calculate what is going to be the number stored in our variables when the overflow takes place. Okay, you can imagine your numbers as endless connected stream that is like in circle connected of those ranges of numbers that are at our disposal. In this case, ranges from 0 to 255. So the orange part here is our regular range, so the one that would be available to us without an overflow happening. And as you can see, it goes from 0 all the way to 255. And now, if we start adding numbers on top of the maximal value, which is 255, you can see that we are going to be continuing from number 0 and then increasing from there. So basically, if we add 1 to 255, we will get the result 0. And now, if we go in the other direction, so basically going less than 0, you see that if we subtract 1 from 0, we will get 255 as a result. Now, in our case, we have 4 minus 255. So we have 5 values that we can subtract before starting to subtract from another range of numbers, so to say. So we have 4, 3, 2, 1 and 0, which means that we have 5 numbers to subtract before we are going to start looping from 255 again. So when we subtract 5 from 255, we get 250, and when we subtract 250 from 255 in the next range of values, we are going to get 5 as a result. Which is why we actually got 5 as a result instead of whatever you were expecting. So this is really an expected behavior. I know that all this might seem like not such a clear and simple topic, but if you remember our discussion about the floating point numbers, I mentioned 2's complement algorithm. Well, this right here that I just explained to you is basically 2's complement at its finest. So this is that same algorithm, and you can use it to actually calculate which value will you get after overflow takes place. So I hope that you managed to understand how things work, and I gave you my personal way how I like to imagine things in order to calculate what value will be stored in the variable after the overflow has taken place. And now, my dear friend, you know how to get each value from our examples. I hope that right now you're feeling comfortable with working with overflows and that if they happen to you, they will not cause too many headaches because you will know how to prevent them and how to handle them gracefully. Which is what matters the most because overflows are going to happen either way. I hope that this video was very useful to you and I hope that you enjoyed it nearly as much as I did making it. In our next video, we are going to be starting a discussion on one of the most essential topics. We will be talking about characters in Rust, so char data type. So things are starting to get more interesting with every passing day. I hope you will be joining me in the next video. Have an amazing day and goodbye.